Polluted water is passed through a series of filters. Each filter removes 90% of the remaining impurities from the water. If you have 10 million particles of pollutant per gallon originally, how many filters would the water need to be passed through to reduce the pollutant to 500 particles per gallon? This is an exponential model. It's actually not growth, though, because if we're looking at the amount of pollutant, it's decreasing. However, we can use the same model. P sub n equals P naught times 1 plus r to the n. The only difference is that r will be negative, because instead of growing, we're decreasing. We know that our filters remove 90% of the impurities. That means that we're decreasing by 90%. So we have P sub n equals P naught times 1 minus 0.9 to the n. P naught is the initial amount that we have. We have 10 million particles per gallon. So we have P sub n equals, I'm just going to leave this as in millions, so 10. And then this is 0.1 to the n. And n here is not representing a time frame anymore. It is representing the number of filters that the water is passing through. We want to end up with 500 particles per gallon. All right, so from 10 million to 500 particles per gallon, we actually should probably keep this not in millions because we're going to get to 500. So writing that as millions would be kind of annoying. So we've got 10 million particles per gallon. We want this thing to end up equaling 500. So 500 equals 10 million times 0.1 to the n. Now, if we divide both sides by 10 million, we have 500 over 10 million equals 0.1 to the n. To solve for our exponent, we need to use a logarithm. We will take the log of both sides, and it doesn't matter the base on the log. Generally, we do log base 10. So we have log base 10 of 500 over 10 million equals log base 10 of 0.1 to the n. But our log rule tells us that n can now come out in front. So n times log base 10 of 0.1. Now we need to divide by this log base 10 of 0.1. We have log 500 over 10 million over log base 10 of 0.1, and that will be n. Plug this into our calculator. We have log, so there's our log, we're doing base 10 of 500 over 10 million, and then we are dividing this by a log base 10 of 0.1. We hit enter, and that gives us about 4.3. Now, in this problem, we have n equals about 4.3, but we have to think about the context of this problem. The problem is telling us that we're passing through filters to get the 500 particles per gallon, and it doesn't make sense to pass through 0.3 filters. So in order to get down to below 500 particles per gallon, we would have to pass through 5 filters.